to get started now. Welcome and shalom to the another seminar in our Australia-Israel Scholars Seminar Series. I'd like to start by acknowledging the Turrbal and Yagara people as the traditional owners and their custodianship of the lands on which we meet today. I'm standing on Turrbal and Yagara country, and I pay my respects to their ancestors and their descendants. And I also extend that respect to the other countries in Australia where we're tuning in from today. In the room today, we are joined by staff and students from the University of Queensland and academics and students from across Australia. So welcome. I'm thrilled to welcome Ayelet Baram-Tsabari, a former science journalist, and she is a professor of science education and communication at the Faculty of Education in Science and Technology at the Technion. Her research program focuses on supporting public engagement with science and effective science communication. She's a former elected member of the Israel Young Academy and the Scientific Committee of the Public Communication of Science and Technology Network. She is the recipient of the Higher Education Award for Young Faculty Member for an exceptional contribution to society and the community in Israel from the Council of Higher Education. Ayelet hosts a science communication MOOC on edX. Everyone check that out, and serves as an editorial board member on all three leading journals in science communication. So today, Ayelet will present on Does Science Education Help People Identify Science-Related Misinformation? So I'll hand it over to you. Thank you, Ayelet.
Thank you very much, Jo. Thank you. It's an honor to be here. So thank you very much for turning up, and I will share my presentation. Okay, so at this point, you might be asking yourself, what does it mean to do research in science communication? And since this is a very, a question I would ask a few years ago, I will share with you a little bit about what people are doing in my research group. So this is my current research group. And one of us is asking, for example, what is the quality of science-related information available online in different languages? And the way we do it is really to take 21 different languages and using the same code book to try and see what's the quality of the first page Google results people get when they search for the same things, but in different languages. Another question is, can citizen science projects serve as a pedagogy for science education? So I have a student who looked at public participation in science as a tool, as a pedagogy for geography and citizenship education, for example. We ask a question like how to support scientists in communicating science more effectively, which is my baby project. So we're developing technology-enhanced and AI-powered teaching and assessment tools to help scientists to communicate with the wider audience. For example, the jargonizer, which highlights different words that could be regarded as jargon, or the half-life writing exercise, which helps scientists distill their message. Inbal, my postdoc, asks, does generative AI support informed public engagement with science and evidence-based decision-making? And Yael is asking, do people who know more science make better science-related decisions? And this is what we'll touch upon today, asking a more specific question about misinformation. So as you know, science-related misinformation is abundant. If you remember, in the beginning of the corona, Trump suggested in a press conference at the White House that injecting bleach could fight the virus that causes the disease. So it's really important to understand that when we say misinformation, it doesn't have to be framed as a claim. So he didn't say bleach will cure the virus, but as a question. So do you think, let's entertain the idea that we should definitely check if drinking bleach or injecting bleach could fight the virus. And despite warnings from health experts on the dangers involved in that, following his comment, there was an increase in Apple's accidental poisoning. Now, of course, this is not causation, this is correlation, but still, I think it tells us that misinformation can have real-world consequences. And misinformation has a capacity to damage public health and the health of democracies, okay? So it discourages health protective behaviors like vaccination and safe sex and healthy nutrition. It can lead to unnecessary public panic. It can fuel intolerance, racism, and fear. But I think most importantly, it harms our ability to create a shared evidence-based worldview and erode public trust in official institutions and experts. At this point, you might be asking yourself, can you define what you mean when you say misinformation? So in this presentation, misinformation is an umbrella term referring to any information that turns out to be false, regardless of the intention. So if people knowingly or unknowingly shared it. And science-related misinformation would be information that contains scientific errors compared to the available knowledge at the time. And of course, in the case of coronavirus, this was a moving target. Now, people often lack the time, motivation, and expertise needed to critically assess information to form an accurate understanding of the world. And this is where education should provide students with the best possible tools to make these informed decisions. Now, the goal of science education to all learners, so not teaching only the people who would like to become scientists later, is to become competent outsiders who are able to interact with sources of scientific expertise in ways that help them to achieve their own goals. But science education really in this role needs to equip students with the necessary tools to assess reliability of information related to science, even if they don't understand the science itself. So this is from the PISA framework, the framework that we use, that OECD used to write the international comparison exam. It says, when it comes to scientific information, both valid and misinformed, all citizens need the competency to judge the credibility and value of the information that commonly surrounds any science-related issue. Now, there's many cognitive and socio-affective factors that contribute to the formation of false beliefs. And there's the issues of analytical thinking and knowledge, but also source cues. So is this source aligned with my political identity, emotions, worldviews? So is this content aligning with my political beliefs, for example? Familiarity with the message. When the message sounds familiar, it also sounds true. And I think maybe the biggest problem, lack of attention. We do not stop to reflect and deliberate. So even if people are equipped with the needed knowledge and skills, they may not use them to make decisions. So I'm going to show you now results from 2 studies that are submitted at this moment that my students ran to find if science education helped people identify science-related misinformation. So the first one by Shaked, we did a data collection during the second wave of COVID-19 outbreak in Israel. One is a representative sample of the general population, and one is ultra-Orthodox Jews collected by phone, a representative sample of religious Haredi subgroups. Now, this allows for a little of a natural experiment, capitalizing on our diversity, because the ultra-Orthodox Jewish community in Israel is a significant minority, and STEM education is not emphasized and is not valued in this community. Haredi women could usually study science up to the age of 15, and it would be termed the wonders of creation. So it's not about inquiry, it's not about skepticism, it's about glorifying the creator. And boys rarely study science or math beyond 5th or 6th grade, so the age of 11 or 12, as this is perceived unnecessary knowledge for the life of a pure scholarship. So we have a group of learners, people who learn a lot, many years, they value learning, they just don't value science education. So the first thing we asked these people was, there are many rumors about COVID-19. Tell us about one you did not believe. How did you decide whether to believe it or not? So the first question we have to answer is, can people identify misinformation at all? This is the representative sample of the general population. And you can see that we manually coded what people said as identifying misinformation correctly. For example, I didn't believe that children are less likely to get infected with corona, or identifying misinformation incorrectly. For example, I didn't believe that it is a virus. Or some people didn't identify any rumor at all. I did not hear anything. So a little more than half of the sample was able to identify misinformation correctly. but another quarter didn't. So they found something that was actually true and said it was misinformation. And another 20%, they couldn't remember anything they heard that sounded untrue. Let's look at the people with very limited science education, how they identify information. Is there any difference? So you can see that 1/3 were able to correctly identify misinformation. For example, I didn't believe that bleach can be a cure. Another third incorrectly identified something true as misinformation. For example, I didn't believe that people died from COVID-19. And another third didn't identify anything at all. I don't recall. So the first take-home message is that it is hard to identify science-related misinformation during a health crisis. It's not something that is easy to do, and just because people are stupid, they don't do it well. What correlates with people's ability to correctly identify misinformation? Is it gender? No. Is it age? No. Is it general education? Not in our samples. However, general science knowledge and science knowledge in the context of COVID-19 were somewhat positively correlated with their ability to actually correctly identify misinformation. Also, expressions of mistrust. So a general skepticism really helped people to identify misinformation, but mistrust in official institutions, so the institutions that should give you the correct information, was negatively correlated. So it made it harder to identify misinformation correctly. Now, critical evaluation skills helped both samples. What kind of evaluation skills? Both looking at the content and looking at the sources. But our question was, does misinformation detection is being supported by science education? And you can see that in the general public, when people have more science education, they also are better somewhat at detecting misinformation. But in the ultra-Orthodox group, we didn't find such significance, such a difference, maybe because of the type of science education people receive. So our second take-home message, more science education and more science knowledge somewhat help to distinguish science-related misinformation. And critical evaluation skills and skepticism help regardless of scientific background. We studied this question using another tool. So what Yael and Karen did was, during the second wave of the COVID outbreak, they used the same sample, a representative sample of the general population, and they tried to measure science-informed behavior. So they looked at adherence to social distancing guidelines or recommendations. For example, do people want to have more guests at a wedding that is allowed? Are they going to visit elderly family members although they're told not to? Would they send their child to school after sharing an elevator with a verified COVID-19 infected individual? And then we ask people justify the chosen behavior. So tell us what you would do on these dilemmas and then justify your decision. And we ask them actually, if you had to convince your parents or spouse, what would you tell them? What arguments would you use? So first of all, I will tell you that there's no connection between how much science education have and the decisions that they make, okay? So the decision to follow recommendations or not follow recommendations is irrelevant to science education. But we were interested in the question of, are people relying on misinformation to justify their decisions about observing social distancing guidelines? So for example, when we asked, would you send your child to kindergarten where the staff lives in a city with high positive COVID-19 rate, while your family lives in a safe city? You can see here that when justifying their decision, people who had more science education relied less on misinformation. Or suppose you have an adult parent or grandparent living alone. Will you visit them in the coming days? Again, the same picture. People who had more science education used less misinformation to justify what they were doing. So responders with higher levels of science education did not adhere more to social distancing guidelines, but they relied less on misinformation to justify their stance. What kind of arguments do people use to justify their decisions? We divided them into simple ones, into elaborated ones, and complex arguments. And again, you can see that responders with higher level of science education used less simple arguments, that's the one in black, to justify their stance, than responders with mandatory or high school levels of science education. So our third take-home message is that responders with higher levels of science education relied less on misinformation, even if they did not necessarily intend to follow the health recommendations. And let's wrap up with our main question: does science education help people identify science-related misinformation? The answer is probably yes, but identifying misinformation correctly is hard and not correlated with people's decision to follow social distancing guidelines. Science education may have a greater effect on the information evaluation decision-making process than on its outcomes. And a reasonable goal, therefore, for science education might be informed reasoning rather than informed decision-making. And with that, I would like to thank you.